Hello students, welcome to Target IES. I hope you are having a wonderful day. Let us continue with module number 4 of our tension members. And in this module, I am going to teach you a very important concept which is critical failure path. And if a question comes from tension members, then it will be definitely related to critical failure path. See, let me make it very clear. This is not a method. Okay, ये कोई नया method नहीं है. You need not read any new formula. See, the thing is, whenever you are applying, let us say there are two tension members, okay, and it is bolted something like this, okay. So you exactly don't know in which path it is going to fail. It can fail like this is one possibility, let us say 1 1. It can fail like this, it is second possibility, or it can fail something like this. ये भी ऐसे भी क्रैक आ सकता है ना. So this part will be separated and ये जो part है this will be separated. That is also possibility. So there are various type of possibilities. So you should find out in which path you are getting the minimum strength, because if you are applying certain amount of force, obviously if that force is more than the minimum value, then उस path में वो fail होने के पूरे chances है, right? So that is the main reason why we should be knowing what is critical failure path. The question will be given like what is the minimum strength of this plate. If you know in which plane it is going to fail, then obviously you know what is your minimum strength of that, what is your maximum strength of that plane, right? I hope it is very clear. So let us see some concepts which I have missed earlier. ये दो concepts मैंने बोला था कि मैं बाद में पढ़ा दूंगा, length of weld and grip length. See, very simple thing. When it comes to grip length, let us say two tension members are bolted. ठीक है? So two tension members are bolted. So if you are seeing from the side, you will be seeing something like this, right? आपको कुछ इस तरह का diagram दिखेगा. So this is your member number 1, this is your member number 2. You are overlapping and you are bolting it. So grip length क्या होता है? Grip length is your from your washer to washer. See, let us say this is your bolt. ठीक है, यहाँ पे एक washer रखते हो, and then obviously let us say here there is plate 1, here there is plate 2, and obviously यहाँ पे भी एक washer रखते हो, and then you close it with your nut, right? So that's what you do, right? So why do we need this washers? Basically washer क्यों use करते हैं? You might be using this washer, right? Circular washer there will be, in which you will be passing your screw first or bolt first. So that washer is kept to distribute your forces equally, okay? So it avoids the concentration of load from the bolt only at one specific point. तो ये क्या कर देता है? A washer, it will whatever load coming, right, it will be distributed to a wider area. That's it. That's the role of washer. So washer to washer, you can say that is your grip length. So when this grip length, I have told in the earlier concepts in the very first module, the grip length should not be greater than 5 times your diameter. If it is greater than 5 times of diameter, then what will happen? Obviously you can see here, right? So यहाँ पे force आ रहा है P, यहाँ पे force आ रहा है P. So it is similar to, if you are just drawing your forces, it is similar to this, right? TP at some distance X. So obviously it will result in what? It will result in moment, right? It will result in moment or couple equivalent to px. Agreed? So यहाँ पे क्या आ रहा है? एक moment आ रहा है. Because of this moment, bending, what you are getting, to be precise, you are getting bending moment, right? So because of this bending, you will be getting bending stresses. As the stresses are increasing, obviously what will happen? The efficiency of this joint, stresses बढ़ते जा रहे हैं. So obviously the efficiency of joint, it will go on decrease. Common sense की बात है. So if your lag length, if your grip length is more, then obviously your efficiency of joint, it will be less. Simple सी बात, right? I hope you got the concept. If your grip length is more, then your efficiency of joint will be less. So let us be very clear. Your grip length and your efficiency, it is depending on your diameter of the bolt, right? Your grip length should not be greater than 5 times the diameter. Let us say a plate के thickness काफी ज्यादा है. Let us say this is 10 mm, or let us say this is also 10 mm, or 12 mm, 10 mm, like that, whatever you want. So if you are increasing the thickness from 10 mm to 20 mm, okay, so to keep this within limits, your length of grip should not be greater than 5 times the diameter. So what you do is you will be increasing the diameter of your bolt also. Diameter of bolt आप क्या कर दोगे? वो भी आप increase करते चले जाओ in such a manner that your length of grip will not be greater than 5 times the diameter. But let us say you reach it the upper limit of the bolt which you are finding. Let us say आपने 30 mm या 36 mm bolt already use कर दिया है, okay, and you are not unable to find a higher diameter bolt, and your length of grip is becoming greater than your 5D. Let us say it is in the range of 5D to 8D. ठीक है, length of grip is in the range of 5D to 8D. Then what you have to do, your strength of member is reduced. Okay, if the load is more, obviously you know what is happening. As your LG is greater than 5D, your efficiency of joint is decreasing because additional stresses are increasing. As the efficiency of joint is decreasing, it can easily break. That's why I am multiplying my force which can be taken by this tension member by a reduction factor, so that it will be safe. Okay, so my load carrying capacity will not be P anymore, it will be P into certain reduction factor, and we need not go into that. But if your LG is greater than 8D, ठीक है, आप यूज ही नहीं कर सकते हो, रिडक्शन फैक्टर कुछ काम नहीं करेगा, इट इज यूजलेस. इवन इफ यू आर अप्लाइंग minimum force, even if you are applying minimum force, a very less force, there is a huge possibility that your member is going to fail in tension. I hope it is very clear. So what you have to do, if your LG is greater than 8 times the diameter, then what you have to do, you have to redesign it. You have to redesign it. Bolt diameter बढ़ाने की कोशिश करोगे, if bolt maximum limit is reached, you can't do anything, you have to go for complete redesigning of your tension members. Done. So let us come to this important topic, which is critical failure path. So coming to critical failure path, so what are the various factors which are affecting your critical failure path? एक हो गया pitch, दूसरा हो गया gauge, sorry, S or P. This represents pitch. Okay, so pitch is generally, obviously P you will be representing in easy language, but if you are opening any textbook, standard textbook, it will be represented as S. So I am leaving it to you. PRS, it will be representing your pitch only, and G obviously for your gauge, N is number of bolts, and D is diameter of bolts. So these are the four important things which actually decide in which path your plate is going to cut. ठीक है, I hope it is very clear. So pitch, gauge, number of bolts, diameter of bolts. So what is this pitch? अरे यार pitch कुछ भी नहीं होता है if the force is being applied. Okay, let me draw it clearly. So you might be knowing the pitch by now, right? Okay, so if the force, let us say this force I am representing by F because it could confuse you with the pitch. So force in this direction, okay, the force is applied in this direction, right? So this distance, the distance between two bolts in the direction of force, that we are calling it as pitch, and the distance of the bolts perpendicular to the direction of force, we are calling it as gauge. बस इतनी सी बात है. So there are four important things which decide your critical failure path. One हो गया pitch, one हो गया gauge, one हो गया number of bolts, and next is diameter of bolts, right? Pitch, gauge, and bolts, which is number of bolts and diameter of bolts. That's it. So you know this formula, right? आपने ये formula देखा होगा पहले. You might be remembering this formula. ये कहाँ का formula है? A net का formula है. A net formula. So in A net, if there is no staggering of bolts, let us say there are 3 bolts. So what you will be doing? Your A net will be nothing but B minimum, which is, let me change the color, which is the total breadth minus the diameter of bolts, agreed or not? So यहाँ पे कैसे है? There are 3 holes here, right? So you have to subtract from your total width, you have to subtract this size of your bolts, agreed or not? So what I am doing, my B will be total B of the plate minus 3 times the diameter of my bolt, agreed or not? That will be the net area of this, net width of this section, agreed, into the thickness of plate. Obviously these plates have certain thickness, right? The plates which you are attaching with the bolts, obviously they have certain thickness, so that you will be using. So your A net will be nothing but B minus 3D into T, right? So it is very simple. But what if your bolts are staggered? What if you have a staggered bolt combination? So in this case, I have told you have to use P square by 4G formula, right? So same B minus ND plus sigma p square by 4g. Right, you have to use this one. So for this set you have to use p1 square by 4g1 square, and for next set again you have to use p2 square by 4g2 square. बस इतनी सी बात है, you will be getting your answer. ठीक है, so I hope you can do that. So let us see in which path, in which way your plates are failing. ठीक है, at critical path for each inclined leg corresponding p square by 4g values must be taken. अरे यार ignore this, there is nothing much. So he is saying at each inclined leg, so let us say you have bolt something like this. So what is the first inclined leg? This is your first inclined leg, right? This is your first inclined leg. Bolt क्या हो रहा है? It is not in the same plane, so this will be considered as my first inclined plane. So now the bolt is here. So again there is no bolt below that, right? There is no bolt below that. Next bolt is again inclined, so this will be my second leg. Okay, I hope you got it. So if you have something like this, then how many legs you have? How many inclined legs? 1, 2, 3. There are 3 inclined legs. That's how it is taken. Okay, so for each inclined leg what you have to do? You have to add p square by 4g. For each inclined length what you have to do? You know the pitch, you know the gauge. So you know the pitch, you know the gauge. So what you have to do? You have to add p square by 4g for each and every leg. That's it. So now coming to this plate, there is one small example here. Let us try to understand here what is happening. So in which way my plate can fail? There are various combinations. So let us see. The bolts are something like this, right? So first combination, it can fail like this, right? It can fail like this. The second combination, it can fail like this also. The third combination, it can fail, it can cut like this, right? That is also a possibility, right? So next it can cut like this, or if you have some other way, अगर आप सोच सकते हो, हाँ, obviously it can cut in that way. ठीक है, जितने possible ways है, in that way it can be cut. But let us see which is a critical path. Okay, which is critical failure path. Obviously what is critical failure path? Along which my a net is minimum. A net जिसके along minimum बन रहा है, so that will be my critical failure path, because stress into area will be given your force, right? If you are multiplying this with the stress which my plate is carrying, I will be getting my force which my plate can take. As simple as that, right? So obviously it depends on my a net. A net eventually depends on what? Thickness तो constant रहेगा. Only thing which is changing is width, b, right? b minimum is changing. Thickness तो constant है. b minimum it is changing. It is depending upon in which path you are considering. अगर यहाँ से consider करोगे, so your b will be nothing but total width of your plate minus 2 holes are there, minus 2 into d. If you are considering here b minus 1d. If you are considering something like this, then it will be b minus 3d, because 3 holes are involved. 1, 2, 3, b minus 3d plus, you know what to do. For the first leg you have to add p1 square by 4g. For the second leg you have to add p2 square by 4g, right? So ऐसा करके हम 4 देख लेंगे values. Whatever value is minimum, that will be my critical path. That's it. It is very clear, right? So let us try to understand. In examination you need not waste your time solving all the possible ways. Just by seeing you should be able to say. Let us try to understand the possible ways in which this can fail. So first, obviously it can fail like this. Second, it can fail like this. So for that easiness, let me name certain thing. ये तो इस तरह से fail हो रहा है ना. So it is starting from somewhere here. So let us name this point, this origin point as 1. Okay, and this 2, this 3, and this one 4, right? And then I can name, let us say the failure is along this plane, so I know it is starting from here. So 5, this is 6, and this is 7. Okay, तो first देख लीजिएगा 1 and 2. Tell me in which it can fail. Obviously b minimum किसमें ज़्यादा है? In this it is b minus only 1d, but here it is b minus 2d, right? Your width is less because there are 2 diameters here subtracting, so obviously this is more critical. ये क्या हो जाएगा, दिस इज मोर क्रिटिकल, हियर breadth is less, the a net is less, so obviously my force which can be carried along this plane is less compared to my second possibility. That is very clear. Now let us consider my inclined length also. Let us consider my inclined length also. There are various possibilities along the inclined line also. First, the crack can start from this point and it can propagate like this, then like this, like this. Okay, two legs are being involved, ऐसे भी हो सकता है और ऐसे भी हो सकता है, only one leg being involved और ऐसे भी हो सकता है, one leg being involved. It is up to you. So obviously it's your common sense that if you are going like this, and the second case if you are just going like this, in this what is happening, there are how many bolts, there are three bolts and two inclined legs. Here there are only two bolts and one inclined leg. So your common sense clearly says obviously this should be more critical compared to this, right? So like that you can eliminate various things and decide which is the most critical path. But let us be very clear, don't just blindly go for this. जितने maximum leg है वही आंसर आपका होने के चांसेस नहीं है. There are some possibilities. Let us try to understand. Let us see the first failure plane which is along the straight line. इसमें क्या आ गया था? So what will be your B minimum? That will be B minus 2 times the diameter of bolt. If you are considering this path 1 2 6 3 4, that is nothing but this one, 1 2 6 3 4, two inclined legs, there are two inclined legs. तो यहाँ पे क्या हो जाएगा मेरा फॉर्मूला? So let us say this is the first possibility which I have considered. This is the second possibility in which I am saying two inclined legs are there. So how many bolts are participating? 1 2 3. ये b minus 3d हो गया. यहाँ तक तो ठीक है. But what is the formula afterwards? You can clearly say blindly, sir, यहाँ पे तो तीन आ रहे हैं bolts, so obviously this should be my answer. But यहाँ पे क्या हो रहा है? There is one plus term also, sigma p square by 4g. Right? In case if your sigma p square by 4g is greater than your one diameter also, then this total value will be more than this, and critical failure path will be along the straight line, not along your inclined legs. I hope it is very clear for you, right? So whenever there is a question given, what you have to do, you have to check for both cases what is your minimum width coming. I hope it is very clear, right? तो हम check कर लेंगे for this one and we'll be also checking for my inclined legs. Okay, I hope it is very clear. If you are coming along the straight path, you know your a net will be nothing but b minus 2d into your thickness of your plate. That's it. But if you are considering along two inclined legs, then what you will be getting? B minus number of bolts are 3 are participating along this failure plane. So b minus 3d plus p square by 4g. P ये है g, right? This is p1 g1 and this is p2 and this is g2. So p1 square by 4g plus p2 square by 4g. यहाँ पे मैंने values दे दिया है. You can see, you can solve on your own. Here p1 and p2 are 50 and g1 and g2. Just give me a second. Just give me a second. Yeah, you can clearly see this distance is given 50, this distance is also given 50. तो मेरा p1 p2 क्या हो गया? 50-50 हो गया. And my gauge, it is clearly given as 100 and 100. So my g1 and g2 are 100. So just substitute in formula and check. Okay, यहाँ पे आ गया था 250t if I am considering a straight line. If I am considering something like this, then you just multiply these terms and add and check what you are getting. You will be getting in this above example, just solve and see, 237.5t. Now you tell me which is area minimum. 250t or 237.5 into t. Obviously this is minimum. तो क्या हो जाएगा? The strength carrying capacity, the load carrying capacity along that path in which b minimum is less is more critical. वहां पे easy से fail हो जाएगा. That's it. End of story. समझ में आ गया ना? So यहाँ पे दो काफी important note दिए. These are the bits which have been repeated over the years in many examinations, which is the most efficient cross section to resist a tension. देखिए, the most efficient cross section to resist tension is Indian standard flange. Okay, flange क्या होता है? Something like this. That's it. Okay, I plate. This is my flange. It doesn't have any angles coming out. ठीक है? If you are taking an angle, it will be angle section. It will be something like this. If you are taking a C section, it will be something like this, right? It will be something like this. तो यहाँ पे एक advantage बन रहा है कि it doesn't have any unsupported arms. So if you are attaching it to a plate, if you are bolting it to the plate, there is no free arms. The entire body is participating in tension. There is no shear lag concept coming here. But if you are taking something like this, angle section ले लो, यहाँ पे तो आप बोल्ट कर दोगे, this will be in air, so there is shear lag, so load carrying capacity of that particular thing will be less. And next we have C section. यहाँ पे तो और भी ज्यादा पंगा है, because if you are connecting only this here in the two legs, you are going to see what shear lag, right? So your tension capacity decreases. So most efficient cross section is your Indian standard flange when it comes to tension members. And so you have to bolt, right? Let us say these are your plates, you have to bolt. How to bolt so that you will be getting maximum strength. That means आपका क्या होना चाहिए? If you want the strength to be more, it is possible only when your B is maximum, B minimum is maximum. Yani you might have different paths, it doesn't matter, it can go anyway. But if your B minimum of all this is more, okay, B minimum क्या हो रहा है? Let us say there are two possible sections. I am bolting something like this. Let us say there are 3 bolts required. So I am bolting like that, and in the second case I am bolting something like this, case 1 and case 2. ठीक है, इसमें B minimum क्या हो जाएगा? B minimum is B minus 3D plus sigma P square by 4G. In this case what is your B minimum? B minimum क्या हो जाएगा? कोई भी सेक्शन के पास ले जो B minus DE हो जाएगा. So even without much thinking I can say, sir, B minimum is maximum in this case. यहाँ पे क्या हो जाए? B minus 3D हो जा रहा है. So the B minimum value is very less. But here my B minimum value is more because it is only B minus D. Yani my minimum area in this consideration is very much, that is my larger part is participating in taking the force, and I will be getting more force carrying capacity, more load carrying capacity. I hope it is very clear, right? So you should arrange your bolts such that your B minimum is maximum. So if nothing is given and you have to bolt 2 bodies, arrange the bolts. And arrangement of bolts is not given in question, then what you have to do, you have to arrange bolts such that we get maximum value of A net minimum or B net minimum. B net minimum का maximum value चाहिए. वो कब possible होगा? That will be possible only when you keep 1 bolt per vertical section. ठीक है? So instead of going, if you want 3 bolts, instead of going to something like this, or instead of going to something like this, you better go to like this. ओके ऐसे करोगे तो B मिनिमम क्या हो जाएगा? ज्यादा हो जाएगा. B मिनिमम इन दिस केस विल बी B minus D. यहाँ पे B minus 3D. You can clearly compare, right? The B minimum value is very less here. B minimum value is very more. That means more area is resisting. So obviously your load carrying capacity increases. That's it, right? So next is slenderness ratio. अरे यार, you all know what is the slenderness ratio, right? It is nothing but your effective length divided by minimum radius of gyration. बचपन से पढ़ते आ रहे हो, इंटर में भी you have studied this in your plus 12 plus 11 plus 12 and then your engineering, right? So you know very well what is this lambda value, slenderness ratio. So why we are studying? In examination there can be question related to the slenderness ratio. Is slenderness ratio काफी important है throughout your steel structures. Whatever topic you are studying, you will be getting the slenderness ratio. It could be in connection, it could be in tension member, it could be in compression member. ये topic आपको पीछा नहीं छोड़ेगा. You should be remembering some values. See, if you are taking a truss, you know the top portion, top layers, as I have explained earlier in earlier classes, will take compression. The bottom members, it will take tension, just like a beam. Just imagine, forget a truss, just imagine there is something, the load is acting from the top, so obviously it will compress at the top and it will be stretched at the bottom, right? The same thing is happening at the top layer. It will be generally taking tension, the bottom layer it will be taking tension, and the members here, they will be subjected to reversal of stresses depending upon the movement of load. If you have completed structural analysis, you will be pandits by now. You can see some tension or you can see some compression, right? Sometimes in the same member you can see compression, and in the same member as the load passes away you can see tension or compression. I hope it is very clear, right? So what you have to do, you have to remember slenderness ratio of various members. ठीक है, compression members के भी याद रखना है. So this is a table which is given in your IES code book, IES 800. So table 3, maximum values for effective slenderness ratios. So all these values could be asked. Any one of these will be surely asked in your GATE, ESC and state PSC examinations in one or other way. So what you have to do, you have to remember all these values. काफी simple and no need to worry. And it's very much logical also. So let us see what are the important slenderness values which you have to remember in our tension members. So first one, a member always under tension. ठीक है, a member which is always under tension, यानी let us take a member, यहाँ पे क्या रहेगा, always tension ही रहेगा, pure tension, subjected to pure tension. So in this case my slenderness ratio can be up to 400, यानी काफी बड़ा member हो सकता है. L effective divided by my minimum radius of gyration can be up to 400. That means you can obviously correlate, right? Your L effective is 400 times your R minimum, काफी ज्यादा. You can even have very long members subjected to tension without much problem. But in compression, obviously you cannot have this much long member. 400 slenderness ratio is not possible, because let us say a member like this and you are subjected to compression. What will happen? There will be buckling taking place, right? The more the length, more will be the buckling, more chances of buckling, right? So what happens? You cannot keep slenderness ratio high in case of compression members, but here you are stretching, right? तो buckling तो आ ही नहीं रहा है. So what you can do, you can take more length also without any problem when it comes to slenderness ratio of tension members, and this is maximum of all the members, which is 400. याद रख लो, काफी important है. So a question can come, what is the length of tension member when R minimum is 20 mm? So you can just multiply. You know the lambda of tension member is 400, so you can go up to length divided by 20. So length is nothing but 8000 mm. तो 8 meters का आप एक member बना सकते हो without any problem of tension member. Then so now comes the very important thing, tension member which is subjected to reversal of direct stresses due to loads other than wind or seismic forces. And next is tension member subjected to possible reversal of stresses due to action of forces of wind and earthquake. देखो याद रखने में problem हो सकती है, but this is very simple. Just remember like this, tension member which is subjected to reversal due to live load and dead load, live load plus dead load, इसकी वजह से reversal of stresses बन रहे हैं. That means let us take some inclined member, tension है, but it is also subjected to reversal because of dead load and live load. In that case, obviously dead load and live load action will be more compared to that of your wind load, obviously, right? Earthquake load तो भूल ही जाओ, कभी वो बहुत सालों में एक बार आता है. Even some structures will never experience it in their lifetime. So it is your common sense that the effect of live load and dead load will be more compared to that of wind load and earthquake load. So in this case, जहाँ पे reversal हो सकता है of my dead load and live load, you should drastically decrease your lambda. Your L effective should be less. Okay, it should be very close to that of compression members, and your maximum slenderness ratio will become 180. ठीक है, तो जैसे lambda कम गया, that means your length of that member, particular member, will be very less. Okay, because L effective is nothing but your lambda into R minimum, right? So what is happening, as your lambda value decreasing, your L effective value is drastically decreasing. I hope it is very clear. याद रखोगे आप, काफी simple concept है. If you have a tension member purely subjected to tension, you can have a lambda up to 400. If it is subjected to reversal of stresses due to live load and dead load, then it is 180. If it is somewhere in between, ठीक है, only because of wind load and earthquake load, you will be getting your lambda value as 350. Obviously you can correlate, right? यहाँ पे क्या हो रहा है? The reversal is very less because of live wind load and earthquake load. सिर्फ इसी की वजह से reversal हो सकता है. There is no dead load and live load which is acting in the reversal of stresses. Then the stresses generated will be very less. So you need not reduce your length of tension member to a big extent. So your lambda value will be somewhere intermediate, 350. So इसका क्या हो रहा है? Obviously your length is less compared to that of pure tension members, but it will be obviously more compared to the length of your member subjected to reversal of stresses due to dead load and live load. So here your lambda value is greater than this value and minimum than this value. I hope it is very clear. तो ये तीन टेबल आपको अच्छे से याद रखना है. And there is one more term which you should be remembering, which is hanger bar. We will study this in later modules, but it is also a tension member. याद रख लो, but it is not of truss element. Okay, we will study this hanger bar later on. इसका lambda maximum होता है 160. इसका lambda maximum होता है 160. We will study this later on. So in compression members topic में जहाँ जब भी आएगा हम पढ़ लेंगे. And moreover, this table you have to by heart, बाबा, याद रख लो. So we have already seen this 400 tension member. We have already seen 350. the tension member subjected to reversal of stresses due to wind load plus earthquake load, and we have seen this, the tension member subjected to dead load and live load. So remaining values are of your compression member के values हम compression members topic में पढ़ लेंगे, but just for now read it once also so that it will be very clear. Okay, I hope it is very clear. So let us meet in the next module in which I am going to start compression members. काफी simple topic रहेगा, मजा है. And before that there is one small topic which is splice. What is this tension splice? अरे यार tension splice कुछ भी नहीं है. देखो, if you have to, let us say if you have to join 2 points which is 20 meters apart, right? ऐसा नहीं है कि आप एक ही स्टील मेंबर लाके डाल दोगे. I have taught you slenderness ratio just now, right? You cannot cast a member as long as you want, right? So obviously there will be small members. You have to join these members so that you will be getting covered in this 20 meters. I hope you are getting this right. So this joining I am calling it as splicing. That's it. उसको क्या बोलते हैं? Joining two sections, we call it as splicing. That is, two sections are joined to make one big section. That's it. Okay, so not that important concept. We will study that in later modules, obviously, as it comes. But I hope you are confident in these topics, right? याद रखोगे. You will never lose marks, right? There are two simple questions of your GATE examinations. Solve only questions which came later than 2008. Even you can solve previous questions. उसमें भी आप कर लोगे आसानी से, कोई प्रॉब्लम नहीं है. So when it comes to your reduction factor, use this formula which I have taught you. Okay, it will be very easy. A net into 0.9 FU by 1.25, where your A net is A1 plus KA2, where your K value is nothing but 3A2 divided by A1 plus A2. ठीक है, sorry, 3A1 by 8, A1 by 8. तो ये एक बार याद रख लीजिएगा. यूज योर फॉर्मूलाज वाइजली एंड यू विल नेवर लूज योर मार्क्स इन टेंशन मेंबर्स. काफी सिंपल टॉपिक है. मोस्टली थियरी क्वेश्चंस विल कम एंड आई एम प्रेटी मच श्योर आफ्टर दिस मॉड्यूल्स यू विल बी एबल टू सॉल्व all the questions. Have a nice day. See you in next module.